Hi there everyone, Mr. Pope from Grammar School for Boys, and I'm going to be looking at the group round from the previous year. So this is 2018 to 2019. Same as before, I'm going to give myself a 40-minute time limit. If I finish beforehand, I'm just going to stop. I'm just going to solve these problems as and when. Let me just set my timer. I'll be thinking aloud. So you can see my thought process here. So 40 minutes. 3, 2, 1, go. Okay, so same usual stuff. First question. Find the value of the sum of the first 9 prime numbers and divide that by the sum of the first 3 prime numbers and then square it. Okay, first 9 prime numbers. So 2 plus 3 plus 5. Next prime number 7, then 11, then 13. That's the first 6. Then after that, the 7th one is 17. The 8th one is 19. And the 9th one, I believe, is 23. And that needs to be divided by the first 3 prime numbers, which is 2 plus 3 plus 5, summed up and then squared. So let's do the easy bit first. 2 plus 3 plus 5 is 10. 10 squared is 100. And then on the top, what I'm going to do is I'm going to try and add things together. So I know that 2, 3 and 5 make 10, so I can cross them off. I know that 7 and 13 make a 20, so I can cross them off. I can see that an 11 and a 19 make 30, so I can cross those two off. And then a 17 and 23, I believe, make a 40, so I can cross those off. I've got a 10, 20, 30 and a 40, which is 100, I believe. So we've got 100 over 100, so the answer is 1. Okay. Next question. ABC is an isosceles triangle with AB equaling to BC. Okay. So, let's see, let's just do it in one. Something like that, where this is A, B is equaling to BC, like so. A point D can be placed on the side AB. Okay, so let's put it there, say, where that's D, such that A to C is C to D, which is D to B. Okay, so that side is the same as that side, is the same as that side. So we've got quite a few isosceles triangles going on here. What is the size and the angle of degrees of A to B to C? So I want to find out this angle here. I'm going to call that angle X. So I can work out these base angles straight away, because it's 180 minus X and then divided by 2, so it's 90 minus X over 2. And now that means this angle here is 90 minus X over 2, because there's an isosceles at ADC. This angle is going to be 90 plus X over 2, because it's angles on a straight line. And this angle here must also equal X, because the triangle DBC is isosceles. So we've actually got 90 plus an X, which is 2x, plus a half x, so 2.5x is 5x over 2. That must equal 180. And now I just solve for x. So if I subtract 90, so 5x over 2 equals 90. So if I times by 2, I get 180. So 5x is 180. So x is that divided by 5. Or if I divide it by 10 and then double it, 2 lots of 18 is 36. So the angle must be 36 degrees. Yeah, pretty tame so far. Okay, the integers a, b, c have the following properties. A is the smallest and b is the middle and c is the largest. The sum of a, b and c is 42. Okay, so a plus b plus c is 42. The sum of the differences is also 42. Right, I've got a c and a c there, so that's 2c. So that's the c's done. I've got a minus b and a b, so they're going to cancel out. And I've got a minus a and a minus a, so it's going to be minus 2a, and this is going to equal 42. If I look at the last one and divide by 2, I realise that c minus a is actually 21. And now I recall properties. if I have two odd numbers, because they're prime, right? Then an odd minus an odd is going to give me an even number. So the fact that c minus a gives me an odd number means that I must have done an odd number take away an even number to get an odd number, or an even take away an odd. Now there's only one even prime number and it's 2, so that's pretty obvious that a is 2, and then we can work back that c is 23. And then once we've got that, we've got a plus b plus c is 42. Well, I know what a plus c is, that's 25. So b plus 25 is 42. So it looks like 42 minus 25, 17. Cool, so that was quite easy. Question 4, the first term of a sequence is 0.8. Each subsequent term of the sequence is half the sum of the earlier of all the earlier terms in the sequence. How many terms the sequence is less than 2? So if I've got 0.8, well, let's just do it. What's the sum of 0.8? It's 0.8. Halve it, the next term's 0.4. Well, keep going. We stop when we reach 2, or a number bigger than 2, right? So 0.8 plus 0.4, this sum so far is 1.2. Half of 1.2 is 0.6. The next term is when I sum up all these things, and because I'm doing a partial sum as I go, all I have to do is 0.6 plus 1.2, which is 1.8. And half of 1.8 is the same as half of 18, and then divided by 2, so that's going to be 0.9. And then I add these together, so 1.8 plus 0.9 is 2.7, and half of 2.7 to get the next term, I believe, is 1.35. So now the sum of those first terms, 2.7 plus 1.35, I believe, is 4.05. So the next term after that is going to be half of 4.05, which is 2.025. And at that point, we're above 2. So there's only 1, 2, 3, 4, 5 terms. So the answer is 5 terms. Yeah, no trick to that, just do it. Okay, a grandmother set aside some money to give to each of her 4 grandchildren and her favourite charity. The grandmother gave Alison half of her money. So Alison has half of Granny's money. She then gave Bertie a third of what remained. So Bertie, think about it, if half has been given to Alison, then there's only half left, so g over 2, but Bertie's going to get a third of that. So Bertie is actually going to get the total of what Granny had over 6. If I look at Charlotte's now, next she gave a quarter of what now remained to Charlotte. So mental maths, what's a half plus a sixth? That's 2/3. So there's only 1/3 left of Granny's money. And now Charlotte is going to get a quarter of that. So 3 times 4, so she's going to have a 1/12 of what Granny had originally. If I look at Desmond, she gave a 1/5 of what now remained to Desmond. So Desmond is going to have a 1/5 of, and then what fraction of g is left? Well, halves, sixths and 12ths, they've got a common denominator of 12. So I've got 6/12 went to Alison, plus 2/12 went to Bertie, plus 1/12 went to Charlotte. So 6 plus 2 plus 1 is 9, and 9/12 divided by 3 top and bottom is 3/4. So that means there's only a quarter of Granny's stuff left, so 1/5 times a quarter. So it looks like she received a 20th of what Granny has left. You can probably see a pattern here. It's going wholes, then halves, then thirds, then quarters. So really, grandmother, I mean, we can deduce that she's only got a 1/5 of her money left. But just to confirm, what's the lowest common multiples of halves, sixths, 12s and 20s? Well, let's get it out of 60. Halves is 30 out of 60, plus 6, that's 10 out of 60. 12ths is going to be 5 out of 60, and 20th is going to be 3 out of 60. 30 plus 10 is 40, 5 plus 3 is 8. So 48 out of 60 has been spent. So that means there's only 12 out of 60 left, which is 1/5, which is what we deduced. So the grandmother now has found that she has left exactly 1,440 to give to charity. How much money in total did the grandmother give to her 4 children? So what that's saying is if g over 5 is 1,440, then what is 4g over 5? All we need to do is times this by 4. So 0 times 4 is 0, 4 times 4 is 16, so carry the 1, 4 times another 4 is 16, carried that 1 is 17, carried the 1, 1 times 4 is 4, plus the carried 1 is 5. So it looks like £5,760. Lucky kids. Okay, Patricia. Okay, Patricia has 2 red balls and a yellow ball inside a bag. Okay, so for P, in terms of red and yellow, she's got 2 reds for every 1 yellow. Quentin has 2 yellow balls, so now 2 yellows to the 1 green ball, and Rosemary has 2 green balls to 1 red ball. And I'll put Rose there, not to clarify. Okay, fine. Without looking, Patricia, Quentin, and Rosemary each take a ball from their bag. What is the probability that no 2 balls picked from the bags are the same colour? Give your answer in the form A over B, where A and B are positive integers with no common factor other than 1. Okay, so let's think about it. Either, there's 3 things that could happen. Either the 3 balls are the same, or 2 balls are the same, or none of the balls are the same. You can't just have 1 ball is the same, that's just dumb. Now the 3 balls can't be the same because if you look at it, they don't have any colours in common. So P and Q both have yellows, but Rose doesn't have any yellows. Quentin and Rose both have greens, but Patricia doesn't. And yeah, so you just think about it. So the 3 balls the same can't happen. And we want no 2 balls picked from the bags of the same colour. So we don't want this one. So we actually want the probability that none of the balls are the same. So it looks like there's only 2 options here. If Patricia gets a red ball, then that forces Rose to have a green ball and Quentin to have a yellow. So that's case 1. Or case 2, if Patricia now draws a yellow ball, then that forces Quentin must have drawn a green ball, and that forces Rose to pick a red ball. So in this case, for a red ball for Patricia, it's 2/3. For the yellow ball for Quentin, that's also 2/3, and the green ball for Rose, it's also 2/3. You just multiply them all together, that's 8 over 27. And then for the other one, it's clearly where they pick the other choice, that's 1/3 times 1/3 times 1/3. So it's going to be 1/27. Add these 2 together, you're going to get 9/27, which you can divide by 9 top and bottom to get 1/3. So that's pretty easy. Okay, a newspaper consists of several large sheets of paper stacked together and then folded in half. Each large sheet of paper has 4 pages of the newspaper printed on it, and on each large sheet the total of 4 pages numbers printed on it is 90. Right. How many large sheets of paper make up the newspaper? Okay, fine. So let's say n is the number of sheets, and let's just draw a couple and see if we can develop a theorem here. So the first sheet, well, on the other side is going to be a 1, and then this side's a 2, and then on the inside here is 3, and then on the back of this, if this was down the middle, that's 4. The sum of these, I'll put the sum of the pages here, this is going to add up to 10, right? Because 1 plus 2 plus 3 plus 4. Okay, now let's say I had 2 sheets of paper, okay? So this is the bottom stack, and then we're going to put another one directly upon it over there. So there's the middle, there's the middle. So if I imagine what's going to happen, you're going to have 1 on the outside of that bit, then 2 here, then 3 on the outside, then 4, and then it works back down. So 5, 6, 7, 8. Now we're going to check the sums work on each page. So 2 and 8 is 10, 7 and 1 is 18. So that one's 18. If I look over here, 4 and 6 is 10, 5 and the opposite number is also 8. So yes, 18. Interesting. Let's do one more. In the case where there's 3. So 1, 2, 3. Well, same deal. 1, 2, 3, 4, 5, 6, and then working back down, 7, 8, 9, 10, 11, 12. 1 plus the 11 is 12, 2 plus 12 is 14, 14 plus 12 is going to be 26, then 4 and 10 is 14, 3 and 9 is 12, 14 add 12 is also 26, then 6 add 8 is 14, 5 and 7 is 12, yeah, so all their sums are 26. And shock horror, we're just adding things here, so we would expect some kind of linear progression, and clearly it's just adding 8 each time. So it looks like the sequence is just 8n plus 2. Okay, so for the sum of each sheet, it's just 8n plus 2. We're told that the sum of the total of the 4 pages on it is 90, so we just set this equal to 90, so 8n equals 88, so n must be 11. That must mean there's 11 large sheets in order for the totals on each 4 pages must equal to 90. Yeah, pretty easy. Okay, how many ways can 45 be expressed as the sum of at least 2 consecutive positive integers? Okay, well, if you've been doing Sudoku long enough, you'll know that 45 is just 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9. And the trick here is that you need to break 45 down into its factors. So 1, 3, 5, 9, 15 and 45. I think that's got something to do with it. Because how many numbers are here? There's 9 numbers. 9's a factor. And when I do 45 divided by 9, I get 5, this middle number. So I can add them in pairs and everything will be fine. So if I have 5, then 4 and 6 will make a 10, this 7 and 3 will make another 10, this 8 and 2 will make another 10, this 9 and 1 will make the fourth 10, so that will definitely add up to 45. If I do 45 divided by 45, I get 1. So this isn't going to be nice, but what we're going to have to do is we would have 0 and 2, so there's the 1, and then we'd have minus 1 and 3, because technically what I'm doing is I'm adding 2 every time. So that's adding 2, that's adding 2, and then if I do minus 2 and 4, that's adding another 2, and so on and so on. And I do this so there's going to be 45 numbers here. The problem is we need positive consecutive integers, so this one's definitely out, I'm afraid. So that one doesn't count. If I do 45 divided by 15, that will give 3, clearly. So same deal, I could have 45 with 3 in the middle, so I could add a 2 and a 4, I could add a 1 and a 5, a 0 and a 6, but then I'm going to go into the negatives, so that one's not going to work either. If I look at the 5, 45s into 5 go 9, so is there a sequence of 5 consecutive numbers with 9 in the middle? Well, if I have 8 and 10, and then I go 7 and 11, let's see what happens there. Well, I've got 9 in the middle, and I've got 18 there, and I've got another 18 there. So 2 18s are 36, plus the 9 is 45, so that works. So this is my sequence of 5 numbers. So that was okay, that was okay. What about 45 divided by 3? Well, that's 15, so can I have 45 with 15 in the middle? Well, yeah, I just have to add 30, and that's easy. That's 14 and 16. They're consecutive, so that one works as well. And 45 divided by 1 is 45. Well, yeah, 45 is just itself, but it's at least 2, so that's not going to work. Okay, now we've got 3. Are there any special cases? Well, technically, these are all the ones where there's an odd amount of numbers, right? 3, so it works for the 3, the 5 and the 9. Okay, is it possible to do it with 2? Now look, we're given 2, 22 and 23. So actually 45 being 22 plus 23 does work. So maybe it's possible with even ones as well. Wonder why that is. Well, let's try 45 and we divide it by 4. Well, 45 over 4, the next even number, is going to be 11 and a quarter, isn't it? So that means the middle number needs to be 11 and a quarter. Well, even if I have 11, 12 like that, and then I have 10 and 13, This clearly adds up to 46, so that's no good. What about 45 over 6? Well, 45 over 6, well, 42 over 6 is 7. That's going to leave 3 left over, so that's 7.5. So, if I have a 7 and an 8, these add up to 15. And then if I go 6 and 9, they add up to 15. And if I go 5 and 10, they add up to 15. So this is my sequence of 6 numbers that do add up to 45. So that one works. So at the moment, I've got 5 sequences. Is it possible with any more? Well, if you think about it, no, because if you do 45 over 7, that's going to give 6 and 3/7, which is not going to be good because that 3/7 isn't between two numbers. It's the fact this ended up with a half meant it straddled 2. So really, if we're dividing by an even number, it's going to have to split something in half. So maybe 45 over 8. No, it's going to be 5 and 5/8. It's not in the middle, so it's not going to work. I've done the 9s. The 10s, interesting. 45 over 10 is going to be 4 and a half. 4 and 5/10. So halfway between 4 and 5 is 4, 5. So then I have to go 3 and 6, then 2, then 7. So what I'm doing is I'm adding 9 these times. And then 1 and 8, that's okay. But then I'll have 0 and 9. If you think about it, that's just dumb, isn't it? So that's the one we've had already. 45 over 12. That's not good because 36 is going to be 3. I have to add 9, so 9/12. It's not a half, so it's not going to work. 14 is not going to be nice either. Yeah, it's just not going to work. Yeah, actually, to be fair, we could have stopped it here because this is 9. We only had to check the numbers up to 9. So actually, how many were there? There was 1, 2, 3, 4, 5. So the answer is 5 for that one. Okay. A rhombus ABCD is drawn in which BCD is 60. Okay, that's given. A circle is inscribed in the rhombus that touches each side of the rhombus. Okay, right, first of all, I'm going to draw a line from B to D. And if I know this is a rhombus, then this side is the same as this one. It's the same as this one and this one. So that means we've got 2 equilateral triangles sticking out. And if the circle just touches each side of the rhombus, that means from the center of the circle to where the circle touches the rhombus is perpendicular, so that's 90. I know this angle here is 60 degrees, and I want to work out this radius of the circle. Well, I'm told the area of the circle is 12 pi, so that means the area of the circle, pi r squared, equals to 12 pi. So that means 12 equals to r squared, and the square root of 12 is the square root of 4 times the square root of 3, which is 2 root 3. So actually, we've got a 2 root 3 here. So if I want to work out the length of each side of this rhombus, then I've got a right-angled triangle where this angle is 60 and the height is 2 root 3, and I want to work out this hypotenuse. So sine of 60 is root 3 over 2, and this equals the opposite, which is 2 root 3 over h. If I divide by root 3, times by 2 and times by h, I get h is 4. So if that's 4, the whole thing is 8. And if I want the area of one of the big triangles, then it's half of one side 8 times another side 8 times by sine of the angle between them, which is 60 degrees. So sine of 60 is root 3 over 2. I've got a half of that, so that's over 4. I've got 8 there and I've got 8 there. So that's what that is. But then I've got 2 of these triangles that make up the rhombus. So I have to times that by 2. So the 2 and the 4 cancel, so that's over 2. 8 times 8 is 64. Half that is 32, not 36, you silly boy. So it's 32 root 3. Okay. Right, question 10. Zebedee needs to choose a 5-digit passcode for his new phone. Zebedee wants all 5 digits to be different and non-zero. Okay, so all the numbers 1 to 9. Zebedee also wants to have at least 2 squared digits. Okay, so S for square, we've got 1, 4 and 9. And he wants at least 2 prime digits. Well, the prime digits are going to be 2, 3, 5, 7. Okay, luckily for us, there's no overlap there. And he wants at least 2 of each. How many of these passcodes are there? Okay, right, so put it this way. Do you agree that it's always going to be 2 squares plus 2 primes plus, and then either a square or a prime? That's how many combinations we're dealing with. So I want to choose 2 squares from that list of 3. And technically it's the number of, it's the combinations of. So I want 2 squares from 3, so it's 3 choose 2, times by 2 primes from that, so it's going to be 4 choose 2, times by either a square or prime. Now think about it. If I've taken 2 of the squares already from the previous bit, there's only 1 square left. And then the OR is like the total coverage, so think about it. I've taken 2 primes already. There's only 2 combinations. There's only 2 numbers to choose from, so that must be a 2. So what I've actually got is 3 choose 2 times 4 choose 2 times by 1 plus 2, which is 3. So 3 choose 2 is 3 factorial over 2 factorial times 1 factorial. 4 choose 2 is 4 factorial over 2 factorial times 2 factorial, because remember, if I'm using n choose r, that's n factorial over r factorial times n minus r factorial. So what's going to happen? Well, 4 factorial is 4 times 3 times 2 factorial. So that 2 and that 2 is going to cancel, and that 2 is going to cross out with the 4 to make a 2. So I've got a 2 times 3 here. So this whole term here looks to be a 6. And then 3 over 2 choose factorial. I believe this term is going to be a 3, because I've got 3 times 2 factorial on the top. That's what 3 factorial is, so that and that will cancel. And 3 over 1 factorial is just 3. So it looks like I've got 3 times 6 times 3, which is 9 times 6, which is 54. Okay, so now I've got 54 combinations of just picking the numbers, but now I've got to consider that, for example, say I picked all those numbers. I would have 54 combinations if I wrote them in ascending order, say. So in ascending order, if I picked them, I'd have 54. But what if I want to jumble the order? Well, then think about it. I've got those 54 combinations times by, and then I've got a choice of 5 numbers, and then 4 numbers there, 3 numbers, 2 numbers, 1 number. So I've technically got to do 54 times by 5 factorial to get the total combination. What is 5 factorial? Well, it's 5 times 4 times 3 times 2 times 1. 5 times 4 is 20. 3 times 2 times 1 is 6. So it's 120. So I've actually got 54 times by 120. 4 times 0 is 0. 4 2s are 8. 4 1s are 4. 0. 5 0s are 0. 5 2s are 10. 5 1s are 5 plus that is 6. So I make that 6,480 different combinations. So let's do it properly this time. So let's have here 6480. Area of the rhombus is 32 root 3. Number of ways was 5 ways. Number of sheets of paper, that was 11, wasn't it? Yeah, 11. Probability picking 3, that was the third one, wasn't it? Total amount of money, oh, it's 5,000 and something. 5760, 5760 pounds. Number of terms, there was 5 terms and 17, so 5 and 17. So 5 and 17. Size of the angle, oh, that was the isosceles one. I want to say that's 36, and the value of the expression was, so that angle, 1 and 36. 1, 36. Okay, so we'll pause there. I had 10 minutes, 49 seconds left. Yeah, moderately difficult. School name, I'll put Pope. Yeah, a little bit difficult, I suppose. Combination stuff, being able to have a good counting strategy and just slice through that. I mean, I can imagine that if you had no idea what to do with this question, that would have taken up so much time. And it's really nice because it's not a particularly difficult question, but unless you have a counting strategy, then your only chance, there's no way you're listing all 6,480. So you're not going to get that question unless you understand combinatorics. Question 9 was easy. Question 8 you could have done by trial and error, I suppose. That's what I did. Didn't take too long. Question 7, yeah, if you had some kind of idea that it was linear, you could have actually done it by some sigma notation. And I don't know, some abuse of the fact that the sum of from 1 to n was n plus 1 times by n over 2. And then clearly if each sheet counts for 90, then you could have said something like, well, if 90 times the amount of sheets is the total sum, but then there's 4 lots of n pages for every sheet, then this would have been somehow 360n. Maybe you could have equated those two. I'm just spitballing here, but I'm sure there would have been some. You could have done it another way. It's probably more elegant, in all fairness, but I think if you understand, if you're just adding each time, this is probably going to form some arithmetic progression, and you could have I just bashed it out fairly quickly. That was probability. Just be careful. Again, that's just fractions. Yeah, there's probably an awesome way to do that. I mean, for example, if it said how many terms of the sequence are less than, let's say, 200, probably would have used a different method. But because you're increasing for the most part, I mean, obviously not for the second term, but you are from terms thereafter, I would have used a different method, say. That's also easy. Yeah, I thought it was fairly nice in general, this. And as I said before, the Team Maths Challenge is the start for the UKMT. The group round is the first round of the UKMT Team Challenge for the seniors. And it's so important because one question wrong loses you 6 marks. Can you see how, like, on the day you'd get like a 6 like that, and then like that, and then like that? Oh, that's the point. Are these answers correct? Let's have a look. Right, okay, so where are we? So 1, 36, 17, 5, 5,760, third, 11, 5, 32 root 3. Yeah, bosh. So on the day, I'd get all of these 6s ticked. The teacher from another school would be doing this for you, and they'd put a little 60 in there, for example, if you've done well. And your team number, I don't know, it'd be given to you on the day, let's say 17. But yeah, cool. Your problem solving, man. The better you have problem solving techniques and the more tools you've got in your toolkit, the easier and more importantly, the quicker you can solve these kind of questions. They're not deep, but yeah, just be efficient really. Okie doke.